And the next very interesting principle we have here is today's session, pigeonhole principle. So what is all about this pigeonhole principle? So it talks about some pigeons, right? And we do have a pigeonhole. And later on we will just relate it to a mathematical problem. Now in general we will see what is all about this pigeonhole principle. Suppose if I have n number of pigeons, alright? If I have n number of pigeons and m pigeonholes, right? And the condition is that n is greater than m. Always we should have more pigeons when compared to that of the pigeonhole. That is a condition to apply the pigeonhole principle. So now with this condition I can say that at least there will be 2 or more number of pigeons in the pigeonhole, right? Or I can say that in other words, 2 or more number of pigeons can be accommodated in the pigeonhole. So that is what about this pigeonhole principle. Suppose say for example, if I have 5 pigeons, right? If my n is 5 and if I have only 3 pigeonholes, so my m is 3. In that case, my n is greater than m, fine. So then what this pigeonhole principle says is that each and every pigeonhole can accommodate 2 or more number of pigeons. So now see here, I have got 5 pigeons. These 5 pigeons will be accommodated each one over here. Then there will be 2 remaining and that 2 can be placed in any one of these. So which means that 2 or more number of pigeons can be accommodated. So now see here, if n pigeons are accommodated in m pigeonholes and n greater than m, then at least one of the pigeonhole will contain 2 or more pigeons. Mathematically speaking, we can say that this should have integral part of n minus 1 by m plus 1 pigeons, right? So this integral part, where this integral part is nothing else but which is less than or equal to this number, and that should be a real number. Real number that should be less than or equal to the integral part. Integral part. Suppose say for example, if I have 3.75, I can write this to be as 3. So which is a real number, right? So this is what about the pigeonhole principle, right? Keep in mind that always your number of pigeons should be greater than your pigeonhole. Now let us see a very good example which everybody in day-to-day life will be coming across, right? So here we have a problem. A man hiked for 10 hours and covered a total distance of 45 kilometers. So a man traveled for 10 hours and he covered a distance of 45 kilometers. It is known that he hiked 6 kilometers in the first hour. So in the first hour, he hiked 6 kilometers, right? First hour, like he hiked 6 kilometers and only 3 kilometers in the last hour. Last hour is the 10th hour. He hiked how many kilometers? 3 kilometers. This is what is given. Now 10th hour. Show that he must have hiked at least 9 kilometers within a certain period of 2 consecutive hours. Let us check out. So totally he has hiked 10 hours and covered a distance of 45. And it is given that first hour he has covered 6 kilometers and 10th hour, that is the last hour, he has covered. So put together I have got 9 kilometers, right? So from the first and the last hour he has traveled or covered 9 kilometers. So totally how many kilometers are left from my second hour to my 9th hour, right? 4th, 5th, 6th, 7th, 8th and 9th, since because the first hour and 10th hour distance is given. So now with these I will have to find out the remaining kilometers. So that is 45 minus 9, I get 36 kilometers. So this 36 kilometers should have hiked between this hours, and that I will have to say that at least 9 kilometers he must have hiked. So now it is a condition for 2 consecutive hours. 2 consecutive hours now. I'll have 2, 3 as 1 consecutive time, 4, 5, 6, 7, 8, 9. So how many periods totally I have? 1, 1, 1, all these. So time period is 4 time period, which means that it is said that 2 consecutive hours I'll take it as 1 time period, and how many kilometers are left out? So 36 kilometers are left, right? So now whenever we will have to apply the pigeonhole principle, I have said that the number of pigeons should be greater than your pigeonhole. So whichever is greater, that I will have to take it as pigeons. So in this kind of a problem, we will have to fix up your pigeons and pigeonhole in an appropriate manner. See to that always the pigeons is greater than your pigeonholes. So in that case, my n, it will be equal to 36 here and my m is equal to 4. And now our intention is to show that he must have hiked at least 9 kilometers within a certain period of 2 consecutive hours. So now we have mathematical formula as integral part of n minus 1 by m plus 1. So this is equal to integral part of 36 minus 1 by 4 plus 1, which is equal to integral part of 35 by 4 plus 1, which is integral part of 8.75 plus 1, which is 9 kilometers. That is what we are supposed to. See, what a beautiful thing. So how do we apply this pigeonhole principle is very, very important. That is, we will have to fix up the pigeons and the pigeonholes appropriately, and then immediately we will be getting the solution for the problem. So, right. So, only thing is that where we will have to put our mind and we will have to break our head is that in selecting the pigeons as well as your pigeonholes. That is very, very important. Okay, let us look for another example also here. This is a very interesting and day-to-day life. We will have friends, we will have enemies, and that we will see here. Prove that in any group of 6 people, at least 3 must be mutual friends or at least 3 must be mutual strangers. So, this is very obvious. So, there are 6 group in a people. So, among these 6 people in a group, we will fix up one particular person. So, that particular person, we are supposed to prove that either he will have 3 mutual friends or he will have 3 mutual strangers. So, now let me fix up one person be fixed among those 6 persons, right? So then how do I'll have only 5 persons will be remaining for my problem, right? 5 persons will be remaining in the problem. And now the next thing is that I do either have mutual friend or I'll have mutual strangers, right? For this person, I am supposed to prove that either I'll have 3 mutual friends or 3 mutual strangers. Let us see. So, among those 6, I have fixed up one person. So, therefore, the remaining persons will be 5, and these are the 2 things we will have, that is 2 groups we will have, mutual friends, mutual strangers. Now, we will have, if we have to apply the pigeonhole principle, I have said you already that you will have to fix up your pigeonholes as well as the pigeons. See to that your pigeons is always greater than your pigeonhole. So, now which number is greater here? Very good. My pigeons are 5 here, right? And these 2 are the pigeonholes. M is equal to 2 or the 2 groups of people, either mutual friend or mutual strangers I will have. So, now integral part of n minus 1 by m plus 1. So, that is integral part of n is what here? 5. 5 minus 1 by m is 2 groups of people I will have plus 1. So, that is integral part of 4 by 2 plus 1, which is equal to integral part of 2 plus 1, that is 2 plus 1, 3. See what a beautiful thing we have arrived. So, this pigeonhole principle is very, very important. We will have to break our head in order to fix your pigeons and the pigeonhole. With that, the problem will be solved, right?